Pharmacological activation of autophagy is emerging as a promising frontier in the treatment of obesity and its related metabolic disorders. As research continues to unveil the critical role autophagy plays in maintaining cellular health, energy balance, and inflammation control, scientists are increasingly focused on developing or repurposing drugs that can selectively enhance this process. Compounds like rapamycin, spermidine, and metformin, all of which stimulate autophagy through different mechanisms, are now under investigation not just for longevity or cancer prevention, but as potential metabolic interventions targeting the cellular dysfunctions that underlie obesity. At the heart of obesity lies a breakdown in the body's ability to regulate energy usage, fat storage, and inflammatory responses. Many of these disruptions can be traced back to impaired autophagy, especially in key metabolic tissues such as the liver, muscle, fat, and even the brain. When autophagy is dysfunctional, damaged mitochondria accumulate, lipid droplets persist, and inflammatory pathways become chronically activated. This creates a cellular environment that favors fat storage, insulin resistance, and metabolic inflexibility. Pharmacological autophagy inducers aim to reverse this situation at the root by reactivating the body's own repair systems. Rapamycin, one of the most studied autophagy activators, works by inhibiting mTOR, mechanistic target of rapamycin, a protein that normally suppresses autophagy when nutrients are abundant. By blocking mTOR, rapamycin lifts this suppression, allowing cells to resume their cleanup and recycling functions. In preclinical studies, rapamycin has been shown to reduce fat accumulation, improve insulin sensitivity, and decrease systemic inflammation in obese animals. However, rapamycin also has potential side effects, including impaired wound healing and altered immune responses, which complicate its long-term use in humans. Newer analogs and delivery strategies are now being tested to isolate its metabolic benefits while minimizing adverse outcomes. Spermidine, a naturally occurring polyamine found in foods like wheat germ, soybeans, and mushrooms, offers a gentler and potentially safer approach. It activates autophagy through pathways that are distinct from mTOR inhibition and has shown strong anti-aging and metabolic effects in animal studies. Spermidine supplementation has been linked to improved lipid metabolism, reduced adiposity, and enhanced mitochondrial function, all desirable outcomes in the fight against obesity. Importantly, it appears to do so without the same level of immune suppression associated with drugs like rapamycin. Human trials of spermidine are currently underway, and early results suggest it may be both well-tolerated and beneficial for metabolic health. Other compounds with autophagy-stimulating properties, such as resveratrol, berberine, and metformin, are also gaining attention. Metformin, already widely used to treat type 2 diabetes, may exert some of its beneficial effects through indirect activation of autophagy via AMPK stimulation. This could help explain why metformin improves insulin sensitivity and promotes fat oxidation in addition to lowering blood glucose. These findings open the door to considering existing drugs for new purposes, repurposing metabolic medications as tools to correct autophagic deficits. The appeal of targeting autophagy pharmacologically is that it addresses a foundational cellular process rather than isolated symptoms. Instead of focusing solely on reducing appetite or blocking fat absorption, autophagy-enhancing drugs work by improving cellular efficiency and resilience. They support mitochondrial health, suppress unnecessary inflammation, and help clear out toxic waste products that interfere with hormone signaling. This holistic approach may offer more sustainable benefits with fewer side effects compared to traditional weight loss medications. Still, a cautionary note is necessary. Autophagy is a highly regulated process for a reason. It must be precisely balanced. Overactivation, especially if prolonged or systemic, could lead to muscle wasting, immune dysfunction, or impaired growth. Therefore, pharmacological strategies must be carefully calibrated, ideally using intermittent dosing or tissue-specific delivery systems. The goal is not to activate autophagy constantly, but to restore its natural ebb and flow, particularly in individuals where it has been suppressed by obesity or chronic overnutrition. In summary, pharmacological activation of autophagy represents a bold and exciting strategy for addressing obesity at its cellular roots. Drugs like rapamycin, spermidine, and metformin offer pathways to reawaken the body's innate repair mechanisms, reduce metabolic dysfunction, and promote healthier fat regulation. While these treatments are still in the research or early clinical stages, They reflect a shift in thinking, from managing the symptoms of obesity to repairing the underlying damage that perpetuates it. With continued study and refinement, autophagy-inducing therapies could soon become a powerful new class of tools in the battle against metabolic disease, offering not just weight control, but true cellular restoration and resilience.